Hello, and welcome to Math Matters. I'm Miss Ogden, and we've been talking a lot about proportions and unit rates over the past few days. Today, we're going to use what we've learned to think about proportional relationships. You will need paper and a pencil or something else to write with for this lesson. If you have graph paper, please get that as well. I will give you a moment to gather those materials. Take a look at the table on your screen. What do you notice? What do you wonder? Take a moment to write down your ideas. Let's read this story about Julia. Read the problem on the right of your screen as I read it aloud. Julia is going to an arcade to play games with her friends. Julia's arcade charges $4 per game and no entrance fee. What relationships do you see? How might you create or draw a picture for this scenario? Go ahead and write down any relationships you might be noticing, or draw a picture to represent this scenario. We've been talking a lot about how mathematicians might represent their thinking with a picture or a table. Let's take a closer look. Think about how a picture of this scenario might be connected to a table. Take a moment to write down what you might be noticing. You might notice that the unit rate, or the price for one game, is $4. The unit rate is 4 to 1 because each game costs $4. In the table, we can see that 2 games cost $8. Do you notice that in the picture? We discussed that the unit rate is 4 to 1 because each game costs $4. What do you notice about the relationship between the number of games and the cost of the games? You might have noticed that we can always multiply the number on the left, which represents the number of games, by 4 to get the number on the right, which represents the cost. This is a multiplicative relationship that will work every time. Let's think about how we can use that multiplicative relationship to solve a problem. How much money would it cost for Julia to play 10 games? Take a moment to try to solve the problem on your own. We can multiply the number of games, 10, by $4 to find the cost, which will be $40. Remember, we call this a multiplicative relationship. We can use that multiplicative relationship to create ordered pairs. Ordered pairs, also called coordinate pairs, can be graphed. The number of games is represented by X, and the cost of each game is represented by Y. What do you notice about the ordered pairs and the table? You might notice that each ordered pair always has a number to represent X and Y. This will always be true for every ordered pair you create from a table. Now we are going to learn how to take these ordered pairs to create a graph. I'm going to model how we can graph ordered pairs. I remember that the first number in the ordered pair represents the x-coordinate, and the second number represents the y-coordinate. I'm going to find the x-coordinate on the graph, which for this is 1, and then I'm going to find the y-coordinate on the graph, which is 4, and then I'm going to trace my fingers until they meet right about there. And that is where I'm going to graph my first ordered pair. I'm going to repeat this process for the next 3. So I'm going to find 2 on the x-axis, 8 on the y-axis. They meet right about here. For 3 on the y-axis, 3 on the x-axis and 12 on the y-axis, that's going to go right about here, and 4 on the x-axis, 16 on the y-axis. Now that I've got my ordered pairs on my graph, it's time to connect those points. I'm going to use a ruler, but you can use any straight edge you might have. As you can see, if this line kept going, it would travel through 0, 0. In today's episode of Math Matters, we learned about noticing patterns with multiplicative relationships and how we can represent them using tables, pictures, and graphs. Next time, we are going to continue exploring relationships with a different arcade scenario. Hope to see you then. I'm Miss Ogden. I hope you have a great day and keep on counting.